Action! NOLA MATHMAN coming again for another fun math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to evaluate trigonometric functions utilizing the law of cosines. The concept we're looking at is trigonometric functions. The skill we're looking at is the law of cosines. So with no further ado, let's get into our math adventure. So in this first problem, we will solve triangle ABC, round side lengths to the nearest tenth, angle measures to the nearest degree. What we're doing here is labeling the sides as given. Side C is 7 because it's opposite angle C. Side B is 3 because it's opposite angle B. We're given angle A, which is 41 degrees. So we're going to use the law of cosines to solve the missing angle, which is angle A. We're going to use angle. We're given angle A. We're looking for side A. I'm tripping. So we're given angle A. We're given sides B and C. We're going to use the law of cosines to find the length of side A. So we write down the formula, which is A squared equals B squared plus C squared minus 2 times BC times cosine of A. So we substitute those values for BC and angle A into the appropriate spots. And we're simplifying for A. We're solving for A. So we have A squared equals 3 squared plus 7 squared minus 2 times 3 times 7 times cosine of 41 degrees. We simplify using order of operations. 3 squared is 9, 7 squared is 49. We multiply 2 times 3 times 7, that's negative 42 cosine of 41 degrees. We get a calculator and we simplify that. We will end up with 58 minus, so we don't need a calculator yet. What the NOLA MATHMAN is doing is we're adding 9 and 49. So at this point, we get our calculator out and we're going to simplify 58 minus 42 cosine of 41 degrees. That will give us a value of 26.30 is equal to A squared. To solve for A, we take the inverse of square, which means you're going to take the square root of both sides. We put a lot of digits after the decimal point because we wanted the exact value for side A. So that's why you see 0.302198. You put as many decimal places as possible. And the value of A is going to get us 5.1. We round that to the nearest tenth. So we have now A. Now that we have angle A and side A, we don't need to use the law of cosines anymore. We're going to use the law of sines, which we went through in the last video, and we will now be able to solve for all the missing side and angles. So what are we looking for? Well, we need angle B and we need angle C. So we will use the law of sines to do that. We have sine A over A is equal to sine B over side B. We substitute the three values as given. For angle A, we put 41 degrees. For side A, we put 5.1. We will put sine of B, which we're looking for angle B, and side B is going to be 3, so we put that in the denominator. We're going to cross multiply to get rid of the fractions, and we will end up getting 5.1 times sine of B is equal to 3 times sine of 41 degrees. We divide both sides by 5.1, which will allow us to get sine B, which is equal to the quantity of 3 times sine of 41 degrees over 5.1. We solve for B by taking the inverse sine function of that quantity we've just written, 3 times sine of 41 degrees over 5.1. We plug that into the calculator and we will round our angle to the nearest degree. So angle B is going to equal, so get your little calculators out. The MathMan has figured it out to be 23 degrees. So angle B is 23 degrees. So now we have angle B, and now all we need is angle C. But because we have two angles given, we can subtract the sum of 41 and 23 degrees from 180, and that should give us C, because we need C. So let's see if that's what the NOLA Mathman is going to do. Yes, so we have 180 degrees. We're going to add the sums of 41 degrees plus 23 degrees. That will give us a sum of 64 degrees. And so angle C is equal to 180 degrees minus 64 degrees. And get your calculators, and that will give us a value of angle C will be basically, let's see if I can do that in my head, 116 degrees. NOLA Mathman beat me to it. I'm trying to do it in my head. And so now we have angle C. We have solved all the missing angles and sides of this triangle by using both the law of cosines, which we had to use first, and then from there we can use the law of sines. So we're done with number one. Let's see what the NOLA Mathman does next. Let's do the 3. So now in 3 we have no angles given. We only have 3 sides given. So we know we're going to use the law of cosines because we don't have any angles given. And so what we're going to do is we're going to write the formula. Does it matter which angle we solve for first? No, the NOLA Mathman decided, because there are 3 formulas for the law of cosines. We're just using the one where we're looking for the sine, cosine of angle A. We could have looked for the cosine of angle B or C. So we decided to do it this way. You label the sides, which are opposite the given angle. So 18 is A, B is 10, C is 9. Since we're looking for cosine of angle A, we're looking for angle A. We're going to use the formula A squared equals B squared plus C squared minus 2BC times cosine of A. So we substitute those values in, and so we have 18 squared equals 10 squared plus 9 squared minus 2 times 10 times 9 times cosine of angle A. So what we want to do is use an order of operation. We square 18, we square 10, we square 9. We have 324 equals 100 plus 81 minus 180 times cosine A. We can add 181 together. We get 181 minus 180 times cosine A. At this point, we will subtract 181 from both sides to get rid of that term and move it to the left side. We're going to be left with a value of, get your calculators out, that will give us 143 equal to negative 180 times cosine A. To get rid of negative 180, since it's being multiplied, we will divide both sides by negative 180. It should pop up here. Now we don't have to simplify 143 divided by negative 180. We can leave it like it is. So if the cosine of A equals negative 143 over 180. And so A is going to equal the inverse cosine of that quantity of negative 143 over 180. And so once you get that, you will plug it into the calculator using the inverse cosine, and we will get an angle A, which we will round to the nearest degree. And so A is equal to 143 degrees. And so now we have one of our 3 angles. We have our first angle for this figure, which is 143 degrees. It's always good when you use the law of cosines and you have 3 sides given, you want to find the angle that's the greatest angle. And since A is the biggest angle out of the 3, we solve for angle A first. That's always a good practice to use. Now, once we have angle A, we can use the law of sines to find our other 2 angles. Because we have angle A and we have side A, which is 18. So that's what we're going to do. So we're going to go sine of A over side A is equal to sine B over side B. So we're given 3 of these 4 components. We plug it in, we solve for angle B that's not given. So we have sine of 143 degrees over 18 equals sine of b over 10. We're going to cross multiply to get rid of the fractional components and create an equation we can solve. We will have 18 times sine of angle B is equal to 10 times sine of 143 degrees. We're going to divide both sides by 18 because that's the inverse of multiplication. That will give us sine B. To find angle B from sine B, we know we have to take the inverse sine. And so we have the inverse sine of the quantity 10 times 143 degrees divided by 18. We plug that into our calculator, and we're going to round angle B to the nearest degree. And so get your calculators and do that right now. And we end up with a value of 20 degrees for B. And so that's our answer. So we have one more angle to go, but since you know we already have 2 of the 3 angles, we can add the sums of A and B and subtract from 180 degrees to solve for angle C. So that should be our last step, which you can see here we're doing. And so we plug that in. 143 plus 20 degrees is 163 degrees. We subtract that from 180 degrees, and that should give us angle C, which is 17 degrees. That's what we should get, and that's what we get. So now we have solved for all 3 angles. We're given the 3 sides at the start, so we have nothing else to do. We're finished with the problem. We found all the missing angles. And again, the NOLA Mathman forgot to circle our answer, but on your papers, you want to circle your complete and final answer. So we're done with number 3. So now we're doing a problem that says determine whether triangle ABC should be solved by the beginning with the law of sines, law of cosines, and you solve the triangle. So this is where you get to use the given information and your understanding of the law of sines and cosines to see which one's better. In this problem, you want to use the law of sines because you're given angle A and side A together, so you know you can use that proportion to find the missing sides and angles that's not given. And so since we're given angle C, we can find side C right away by using the law of sines. And so that's what we're doing here. So we put the sine of 71 degrees over 20, which is side A, is equal to sine of 62 degrees over C. We cross multiply, we get C times 71 degrees, sine of 71 degrees, equals 20 times sine of 62 degrees. To solve for C, we divide both sides by the sine of 71 degrees. We get our calculator out and plug in the values and get the quantity of 20 times sine of 62 degrees over sine 71 degrees, and that will give us the value of the side C, which is 18.7 rounded to the nearest tenth. So C is equal to 18.7. Now we can solve for angle C because we're given angles A and C, so we can solve for B by subtracting the sum of A and C from 180 degrees, and that will give us angle B like we've been doing throughout this section. So we're going to do that to find angle B, angle B, because we're given angles A and C. So that should pop up here. 180 degrees minus the sum of the 2 angles that's given, which is 71 degrees plus 62 degrees. That will give us a quantity of 180 degrees minus 133 degrees. And so angle B should be equal, I'm doing it in my head, it should be 47 degrees. Let's see if that's what the NOLA Mathman got. You don't want to do it in your head. I want you to write it on paper. I'm an expert at this. So angle B is 47 degrees. So now we have one more thing to solve for. We need side B. We're going to use the law of sines, not cosine, law of sines to get side B. And so we use sine A over side A equal to sine B over side B. And so we're given 3 to 4 components. We substitute those in. Sine 71 degrees over 20 is equal to sine 47 degrees over side B. We cross multiply, we get B times sine of 71 degrees is equal to 20 times sine of 47 degrees. We divide both sides by sine of 71 degrees, and that will give us the value of B, which is the quantity of 20 times sine of 47 degrees divided by sine of 71 degrees. And you plug that in the calculator, you want to round that to the nearest 10th. And so you get a value of 15.5, which is the length of side B. So at this point, we have finished the problem. We find all the missing sides. So now we're going to do another one. We're going to do number 16. We're given all the sides, but not given any angles. We have A equals 5, B equals 6. C is equal to 7. Now, since we don't have a pair of angles and sides that correspond, we have to use the law of cosines to solve this particular problem. So that's what we do. Now, we have the option to solve for any of the three angles first. In this problem, it looks like we're solving for angle C. So what we do is we write the formula for the law of cosines we want to use. We put C squared is equal to A squared plus B squared minus 2 times A times B times cosine of C. We substitute sides A, B, and C in to the problem, and we will solve for sine the angle C. So cosine C is our unknown. So once we substitute and simplify, 7 squared is 49, 5 squared is 25, 6 squared is 36. We want to multiply 2 times 5 times 6, negative 2, that's negative 60 cosine C. We add 25 to 36, which is 61, minus 60 times cosine C. We're going to subtract 61 from both sides, because that's the inverse of positive 61. We're going to get a negative 12 equal to negative 60 times cosine C. We will divide both sides by negative 60 to get the cosine C by itself. Once we do that, that will give us a value basically of 1/5. And cosine C is equal to 1/5. And to get C, that's 12 over 60, which is 1/5. The NOLA MATHMAN didn't reduce it, but you'll reduce it eventually. And C is going to equal the inverse cosine of 1/5, which he puts 12 over 60, it's the same thing. And so once you plug that in your calculator, you will get a C value of 78 degrees. So C is equal to 78 degrees. So now we have one of the three missing angles. Now we got to get either angle B or angle A. And so we can use the law of sines because we have angle C and side C. So we will put sine C over side C is equal to sine B over side B. So we substitute 3 to the 4 known quantities and we solve for the unknown, which is angle B. So we have sine of 78 degrees over 7 equals sine B over 6. We cross multiply. We get 7 times sine of B is equal to 6 times sine of 78 degrees. We're going to divide both sides by 7 to get sine B by itself. And once we do that, we know the angle B is equal to the inverse sine of that quantity, which is 6 times sine of 78 degrees over 7. We get a calculator out, we're going to plug that in, and we're going to get angle B, which we will round to the nearest degree. So let's see how that turns out. Get your calculators out. The MathMan is trying to figure it out. We put an arrow here, so B is going to equal 57 degrees. So that's the value you should have gotten. Check that out there. And so it's right there. So now we have B. Since we have angles B and C, we can find angle A by subtracting the sum of B and C from 180 like we've been doing. And that's what's popping up here on the screen. And so angle A is equal to 180 minus the sum of 78 plus 57 degrees. What sum is that going to get us? Get your calculators. That should be 135. And then when we subtract 135 from 180, that will give us a value of 45 degrees. So angle A is equal to 45 degrees. We are done with this problem. We have solved all the angles given the sides that were given. So we have all the angles. We have 3 angles, 3 sides. When you have 3 angles and 3 sides for each problem, you know you're done. So we have done a variety of problems using the principle of law of cosines. We've combined that with knowledge of law of sines to find missing sides and angles. And so we're done with another math adventure. So this is the NOLA Mathman signing off. Have a blessed and prosperous day.